Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem reverse level order traversal. So let us read the problem statement and see what we have to do in this problem. So basically, in this problem, we'll be given a tree. So let's say we have been given the tree as 1, then 3 and 2. Suppose this particular tree has been given. So normally, what is the level order traversal? Normally, in level order traversal, first of all, we'll have the node as what? 1. Okay, first of all, we'll cover the first level and then the next level. So normally the level order traversal will be what? 1, then 3 and then 2. But here the question is asking for the reverse level order traversal. So what do we mean by the reverse level order traversal? When the problem is asking for reverse level order traversal, so they want you to do the level order traversal but in the reverse format, from the down side to the upward direction. Okay, so first of all you will traverse these two elements, and then after that this particular element. So first of all you have to write 3, then 2 and then 1. So this is what they mean by reverse order traversal. Let us look at the next test case also so that we can understand this better. So let's say if we have got 10, 20, 30 and then 40, 60. Okay, so let's say we have got the test case where we have 10, then we have got 20 here, 30 as the right child, and then let's say 40, 50, and let's check if we have anything. Okay, so we have 10, 20, 30, then we have 40 and then 60, suppose. Okay, so we have, instead of 50 we have 60, right? So if we have got this particular uh, tree here, so first of all we will traverse this level. Okay, so the answer should be 40, 60. Then after this you will traverse this level, so it will be 20, then 30 and then what? 10. Okay, so you can see here that we have 40, 60, then 20, 30 and then 10. Okay, so this is how we are doing level order traversal only. We are doing level order traversal only, but in the reverse format, in the reverse direction, in the opposite direction. So how can we solve this particular problem? That is the first concern. So in order to solve this, what we can basically do here is, let's say we are given the first test case. So let's say we have 1, then 3 and then 2. So you can observe one thing, that which node is being printed first, right? You have to observe this. So basically, if you see here, the final answer is what? The expected answer is that you should write 3 to 1 here. Okay. So what I'm saying here is, let's do normal level order traversal and let's try and change one thing. We will do normal level order traversal only, but instead of first of all checking the left and pushing it inside the queue, we will first of all check the right node and then push it inside the queue. And after that, we'll check the left node and then push it. So suppose what will happen is, initially in my queue, what will be there? If I'm doing the level order traversal in this changed format, so what will happen is, let's say I will be storing the vector also, right? So first of all, I'll push the node 1, I'll pop it out of the queue, obviously. I'll put it in my vector. Then after this, instead of traversing the left guy, I will go to the right first. Okay, so I'll push the right first. I'll check if the right is not null, I'll push it inside the queue. So I'll push 2 inside the queue. Then after that, I'll check if the left is not null, I'll push it. So I'll push 3 inside. Then after this, what will happen? The next node is 2. So I'll pop out 2, I'll push it inside my answer. And then after that, what will happen is, with respect to 2, the right is null, so I'll not push anything. With respect to 2, the left is also null, so I'll not push anything. Then after this, the next node will be what? 3. So I'll pop it out, I'll put it in my answer. And then with respect to 3, the right is not existing, so right is null. The left is also null, so nothing happens. And you can see that I have got 1, 3, 2 as the current answer. Now if I will reverse this, what will happen? I'll get the answer as 3 to 1. So you can clearly see here, guys, that what I have done is that in order to get the reverse level order traversal as my final answer, what I have done is I've applied level order traversal only, but whenever I am applying level order traversal, whichever node I am at, okay, instead of going on the left, I'm first of all going to the right. Okay, so whichever node currently I'm at, I'm going to the right child, and if the right child exists, I'm pushing it inside my queue, and then after that I'm checking if the left child exists, so I'm pushing the left child inside the queue. Okay, and once we have got the list, then we are reversing it, and that reverse list is basically what? That is basically the final answer that is expected from us. Okay, so let's try and do it for the bigger test case, that is 10, 20, 30, 30, 40, 60. Okay, so let's say we have the test case as 10, then 20, then what? 30 and then 40 and then 60. So let us see how we'll achieve our final answer here. Suppose that I will initially declare a queue. So let's say we'll have a queue initially. Okay, so let's increase the size of the queue here. Yeah, so let's say we'll have a queue and we will have one answer array as well. Okay, so what I will do here first of all is, I'll be pushing the node 10 inside the queue. So I'll push it, right? Then we will first of all pop it out, because we'll be applying the BFS algorithm for level order traversal. Now we will pop out 10 and we'll push it. Now when we are at 10, so instead of first of all checking the left, I have told you that first of all I'll check the right and then the left. So the right guy exists, so I'll push 30 inside. Then the left guy exists, so I'll push 20 inside. Okay. Then next time the next node is 30, so I'll pop it out. I'll push it in my answer. Okay. And then after that, when I'm at the node 30, so its right does not exist, so I'll not push anything. Its left is also null, so I'll not push anything. Okay. Then the next node of the queue is what? 20. So I'll pop 20 out. I'll push it in my answer. Then with respect to 20 on the right, I have got what? On the right, I have got 60. Okay. So I'll push 60 inside. Then after that, with respect to 20 on the left, the guy exists and it is 40. So I'll push 40 as well. Okay. Now what will happen here is, now next time the front of the queue is what? 60. So I'll pop it out. I'll push it in my answer. Okay. Then with respect to 60, the right child is null, the left is also null. So nothing will happen. Then the next node is what? 40. So I'll pop it out. I'll push 40 as well. Now with respect to 40, the right guy is null, the left is also null. So basically this is what my answer is storing finally. And when you will reverse the answer now, so what is the order of elements now? When you will reverse it, so you'll get 40, 60. You can see here we are getting 40, 60. Then you will get what? 40, 60, then 20, 30 and 10. Okay, 20, then 30 and 10. So you'll get what? 20, 30 and then 10. So you can clearly see here guys that what I'm getting here is I'm getting the reverse level order traversal only. So the change that I have made in BFS is that first of all I'm pushing the right child, okay, inside the queue, and then after that I'm pushing the left child, and in that case I'm generating this answer array, and in order to get the final reverse level order traversal, I just have to reverse my answer in order to get the final answer. So I hope you have understood this small manipulation and how it helps. Now let's try and complete the code as well. So what we will do here is, first of all, we will be declaring a queue. So let's say we'll declare a queue which will be storing the nodes. So we'll write queue node and let's name it as queue. Then we also need an answer array. So we'll write vector, let's say int answer. Then after this, because we need to return the answer, then we'll say that while the queue dot size is greater than 0, or you can say that while the queue is not empty, till that point of time we'll iterate, and we will do what? We'll take out the current node. Now the current node will be what? Current node will be queue dot front. So we'll take it from the front, and then we can simply pop it out of the queue. Now once we have done this, so after this, what we will do is we'll push the current nodes data inside the answer. So we'll push the current nodes data inside our answer array, and then we will check. So first of all, I have told you that we will check that if the current right child is not equal to null. If the current right child is not null, so I'll first of all push it in my answer. So what I will do here is I'll simply push current's right child if it exists. Okay. And then after this, what I will do is I will check that if the current's left child is not equal to null. So if it is not null, so I'll push it. So I will do what? I will do q dot push current's right child, left child. Okay, if the left exists. Then after this, once this part is over, so once my BFS will be over, then I need to do what? Then I need to reverse my answer. So I'll write what? Reverse answer dot begin, comma answer dot end, and then what? Then I can simply return my answer here. So this is what we will be doing. Let's try and compile it to check if it is working fine or not. So it is running on the samples right now and it is taking a bit of time. So let's do one thing. Let's directly click on the submit button to check if the code is getting accepted or not. Okay, so it is not working fine for one of the test cases, I guess. Okay, so it says that our answer, we are not able to return it. Okay, so my answer is coming out to be empty right now. So I guess there is some issue with my answer. So let me just check here. So what I have done here is I've got the queue, then I have the answer array, then after that if the queue size is greater than 0. Okay, so one thing that is missing in my code is that suppose if the one base case or one edge case that I have missed here is that suppose if my root itself is null. Okay, so if the root node itself is null, then I should return the empty answer. Then I should directly return the empty answer list. Okay, otherwise what I will be doing is otherwise I should push the element inside the queue. So I'll push the root node inside the queue and then I'll start my BFS. So there were two edge cases that were missing. Firstly, I forgot to check that if the root itself is null, then there will be no level order traversal. In that case, I have to return the empty answer list. Otherwise, what I have to do is I have to push the root node inside my queue. Okay. Now let's try and submit this. Now it should get accepted without any errors because we have rectified the errors. So yes, you can clearly see that my code is able to pass all the test cases, and the time complexity for this code will be same as that for BFS, and the space complexity will be order of n because we are using extra space to store the nodes inside the queue, and we are using one answer array as well. Okay. So I hope you have understood this question clearly. In case if you have any doubts, you can mention them in the comments, and if you have understood it clearly, make sure to comment understood. Thank you for watching this video and keep coding.